Picture an AI recommendation engine perfectly predicting what a user wants. It's functionally flawless, but it takes 45 seconds to load the results. Or consider a machine learning model that makes highly accurate credit decisions but can't explain its logic to auditors. Or a chatbot that successfully resolves issues, right up until it crashes under normal user load. A system that does the right things poorly is no better than one that does the wrong things well. Most of these failures happen because quality expectations are left vague. Telling a development team to make the system fast or ensure it's reliable gives them nothing to test against. These invisible assumptions become the costliest sources of rework late in a project. In earlier phases, functional requirements answered exactly what the AI integration should accomplish. Now we have to lock down the boundaries of how well it must perform those tasks. Quantified quality boundaries act as the filter between a prototype that works on a developer's laptop and a system that actually survives its first week in production. We call these non-functional requirements, or NFRs. Think of them as a boundary layer that wraps around your functional requirements, strictly constraining how the AI is allowed to operate in the wild. To quantify these boundaries, we use the ISO 2510 framework as a starting point, and then add AI-specific attributes. We define parameters for model explainability, fairness, and data drift, attaching measurable targets and specific consequences if the system fails to meet them. Large language models are highly effective at generating comprehensive checklists for these attributes, but they fall into a dangerous trap. Because their training data is full of massive, enterprise-scale documentation, they will confidently suggest targets that don't match your reality. This chart shows the difference between two availability targets. AI often suggests an impressive 99.99% availability, allowing just 52 minutes of annual downtime. Hitting that requires massive, redundant infrastructure and huge budgets. For a standard internal tool, a 99.5% target is far more realistic. This is where human judgment is required. You must calibrate targets by cross-referencing AI suggestions against actual budget constraints and the operational process baselines established in earlier sprints. You also have to navigate the reality that quality attributes frequently war with each other. Imposing heavier security encryption will naturally slow down system performance. You have to prioritize which metric wins based on specific stakeholder needs. AI can hand you the structural categories for system quality, but only human judgment can resolve these technical trade-offs and set thresholds your project can actually survive. This is the Requirements Traceability Matrix, or RTM. It acts as the project's metadata layer. The matrix traces a clear path from foundational business needs down through stakeholder demands, specific use cases, and eventually to the test cases that will verify them. AI can help draft these connections, but you have to watch out for the semantic trap. AI drafts traceability links based almost entirely on vocabulary matching, rather than actual logical dependency. For example, an AI will eagerly link a broad business goal about improving invoice processing to a specific system feature for extracting line items from invoices, simply because both phrases use the word invoice. To fix this, an analyst has to verify the actual logical dependency. You must look at the link and ask, if the upstream business goal changed tomorrow, would this downstream system feature actually break or become obsolete? A maintained traceability matrix provides proof that every technical feature in the build directly supports a business objective. Once the NFRs are quantified and the matrix is fully linked, your project requirements are officially baselined and locked. A completed matrix immediately exposes structural flaws. It allows you to spot orphan requirements, features that nobody actually asked for, and coverage gaps, which are critical business goals that have no features assigned to solve them. NIST Lockdown also prepares you for formal change control, because inevitably, a stakeholder will demand a late-stage change to the project. Before you approve that request, the traceability matrix instantly reveals the impact chain. You can see exactly which downstream artifacts, use cases, and test cases will break if that change goes through. Using this matrix allows an analyst to manage project risk through data rather than intuition. With quantified quality boundaries set and a fully traceable impact chain established, the project team knows exactly what success looks like, and that sets the stage for the final phase, building the test cases to prove it.